Welcome everyone to another open source live stream, as per the title, right? I do even continue fixing all this stuff, all this non-mainstream stuff when people break it faster than we can fix it. Another case in point I noticed the other day already, made a video because we didn't correctly pack our size optimized installer second stage, because for some 1 in 60,000 or theoretically we probably should reduce it a little bit, 1 in like 30,000 or something chance. This binary set the same size for PowerPC, which previously didn't happen. And I that day suspected there is something strange with those binaries. And fast forward 1 week later or so, last night, P3 user of course said, yeah, it doesn't boot anymore, out of space. And I was like, yeah, darn, probably these freaking binaries. And so it's probably better we take a closer look. Maybe theoretically we should have taken a closer look that day. So the problem is, I mean, not only the issue was that all those binaries had like the same size here, as you kind of maybe see a little bit here. And they're also large, right? So they are larger than before. I should theoretically have a other build around. But yeah, you see, I guess there's something strange. That's the point of this video, right? Another low level. This is this strange stuff that happens for decades here. That, yeah, we do stuff, we build stuff. It's probably filling something. So I've like literally not taken a look before, because we are so lazy and the cheapskates that for 25 years we fix everything. But I was actually doing other work, and yeah, leave in the comments below. I mean, some people like this live stuff, some other people. I mean, it's a more random live channel, right? What do you get? Also wonder, should we just actually, aka title. Also, full disclosure, I copied this title from Marina Weisband, German, how to label her? Politician, activist stuff, talk show guest and stuff. And it's like, yeah, copied her title a little bit, like, why not just burn all this freaking stuff down? Save quite some intermediate steps. Don't forget to like, subscribe, comments below. Oh man, yeah, 20 years later, you couldn't. It's also crazy. I mean, the GNU people also, even for x86, they added new node section, because you always need, yeah, why not? Like, yeah, basically they do the opposite, right? Of never touch running systems. Like the GNU and other open source people, like, let's touch everything, new sections, new marks, new ABIs, new. The thing is, it adds a little bit up, right? It's only like 64K, but I mean, 2 years ago we size optimized the heck out of our initRD stuff, not only to profit every system from all the burning vintage stuff, alpha or latest and greatest RISC-V microprocessors, but it adds up, right? If everything is like, instead of, yeah. The thing is also nowadays, I mean, even for a more base minimal system, you have already, I mean, all the libcs, yeah, let's see what we find. And if you have only like 16 megs of memory free on a 256 megabyte, why do we have so little free? Because we load the initial RAM disk, as the name implies, right? Also 20 years ago this was just RAM disk, now it's initial RAM disk. Also previously this was a real file system like X2. Nowadays it's just a special variant CPI, like new variant flavor CPIO archive. That's a kernel extracts into a temporary file system. Previously this was directly mounted to memory, like Linux before 2.6 or 2.4, long time ago, 15 years. So bin, where do we have our, probably here. Wait a second, we probably can, so yeah, one thing is object dump, of course. So how do we take a look? So first we need to find out what's actually freaking going on here. Can do this with do we have a readelf, or this is probably, why do we not have, this is also probably, I'm not even sure. All right, I think we split this to cross CC because we have wrappers potentially or something. Although maybe I should, you know what, let's make a to-do, otherwise we, darn, I didn't tmax that for, all right, also. build PowerPC and let's first read elf. Well, let's so sorted by size. What is OM shell? What? Yeah, I mean nowadays, right? Bash shell is already megabyte. Read elf. Let's analyze something that should be small, like yes, and this is also what was a problem, right? The size, it's for sure filling something with special nodes or whatever. Something of, or do we have cat here? Probably we have cat here, right? And then the problem is also, can you version or not API? The question is, so what we want is actually a list of all the sections. Sections are in this elf, in this, what do I always forget what elf stands for? Extensible link format or what? Something of that sort. Executable linkable format, of course. So what do we got here? So this is all the sections. And where is the size? Is here. Hashes, string strings. So the question. The thing is, it should be somewhat similar to. Let's actually list all. This is 24 architectures, right? Let's list all cats sorted by size. And yeah, so this PowerPC, so that is also crazy, right? Like argue. So this, okay, some are UClibc, but this is actually glibc. So I mean, it's crazy that from 18K and RISC-V is, as the name implies, also RISC-V, right? So there is no reason this. I mean, there's definitely something strange as PowerPCs, even 32-bit PowerPCs should definitely not be larger than even freaking Itanium, which Itanium usually is the largest. It's funny though how even this x86 is relatively large. It's even Musel. Okay, so this is the linker, is the Musel linker is doing. So yeah, you use Musel because it should be smaller and then it's larger. Here are the others. Yeah, so much to twice the size with other libc. Let's read all elf of this RISC-V thing, or even that one. So yeah, it should be like more like that size, obviously. And there you see if everything. I mean, I don't think everything is 3 times the size. I would think it's more like an overhead. Maybe we make ourselves a node. Wait, this was. Why do I do MIPS? Nobody knows. So yeah, quite some sections here though. But the thing is the size init array. So this is what everything makes a program, right? If you're new to this stuff. So what are the sections? This is all the different parts of a program saved in different sections. It's actually not the most interesting. So ironically, like text, maybe I should check where the naming comes from. I always found this text name. So text is the actual program, although it's not really text, it's binary. I would personally, like, I have no idea why they named this text. I probably should research that. I would have named this executable, but read-only data, relocation stuff, init data, so data, all your variables, BSS, comments. So what are even, why is this even, this is a little bit, why is this folded so annoyingly? Can we not have, why is this wrapping, or is it maybe it is by, probably it is not wrapping, this is just by design. So 27, so this is what I wanted to see a little bit, so really many sections. So that is not uncommon. And did I, by the way, make? All right, I actually, what node did I wanted to do? I wanted to ship, just because I found I didn't have. And by the way, this we fixed yesterday already. What did I even want to... clear sign of being burnt out and overworked when you forget within 1 minute what you wanted to make a note about. I guess we will remember, but one test, what I also wanted to, like we could actually make some test suite of binary size sanity check of not building with debug. The other thing what I remembered, I wanted to make a note, like remove and unify this tool chain. Is it? Maybe it's even directly cross CC, it doesn't matter. If we really need that, or if it would be better to just have this in bin, doesn't matter. That doesn't matter so much. Just a little bit cleanup and streamlining and stuff. PowerPC bin cat, so what's going on here? Actually, this is interesting that it prints. Oh, wait a second. This is a section headers. Can it be just symbol table? Maybe we should compare this side by side. You know what? Do you need to read this? Let's. This was a wrong split. What was the other split? This one. Build. Let's read if all. So that is PowerPC, right? What was? Read if PowerPC. Actually, maybe splitting it differently would be, you know what, if we, oops, split it like this, maybe that is a little bit more readable. So let's compare that with risk 5, 32. So size, what do we have there? Okay, that is just the overview. Oh, wait. And then the section headers. Size, so that is tiny. What do we have of significance? So maybe we should first, and welcome everyone. Paul loves the stream title. Yeah, we're trying better with this clickbait stuff, obviously. Can't grow a YouTube channel without clickbait, figured. Hello, can we? There. So, what size is it? Is tiny. Comments, that is tiny. BSS. What is even? Which one was now what? Risk 5. So that is anyways a tiny one if we want to find out. No, so too many key bindings here to keep track of which thing is large. So text is to be, of course, in good old Unix tradition, printed as hex. But that is what people get used to. What is our text here? So I mean the text is actually 1B, 2B. I mean the program. Maybe we should sort that. Is it the only significant? How much is it even? So it is 11K. I mean, that is not that large. I mean, this is not unreasonable, I would say. Oh, wait, I did this wrong. the only large segment I immediately see here, so... Or is it? Wait a second, we have here Dinsen. I hate when this key binding stuff doesn't. Dinsen there, 3F. Okay, that is also not that unreasonable. Do we have anything larger than 2B? I mean, I wonder if maybe we should hex dump that and see how many zeros are in there. I mean, here are, okay, that are not that many. This is just 20 hex. What do we have there? Also very few. We could actually, so this zero filled up with an asterisk, that doesn't also not look like the most. 20 hex. Here, this is just filling with zeros to page size, usually page size boundary. Here's which section is it for? There is some copyright. Also, maybe this is normal. This is normal text copyright for software foundation. Here is a bit though from 4. Maybe that could be something. That is quite a bit. This is from 4A. And previous video, right? The irony that this tempfs stuff, if this would be my kernel, I would have long have compressed page tempfs support. But you can only achieve that with tricks. So that is something, what was it, FFF or something minus Z. Yeah, this looks like 46K if I didn't do that. I mean, that would be exactly something that would match that. This is also exactly what I intuitively also want to do that wrong. This is something that I would have intuitively suspected. Okay, what section is the first one and what is the other? So that is offset, that probably, so here, okay, CTOR, so this is from exception. Is it sorted? This looks like it is sorted here from offset. And also this would be elf stuff that is of course implemented in the, probably a little bit in the Linux kernel, in the dynamic linker, in the GNU bin util, in the compiler and stuff, to deal with this kind of stuff. Yeah, so why does it have such a huge gap there on RISC-V? We have, do we ever have, so we obviously don't have such gaps, so CTORs. So even C code can have CTORs. I guess if you mark attribute, like in C, you don't need to have C++. You can mark, I think this should be the same or equivalent, similar. If in C with at least GNU extensions and GNU and glibc, or maybe probably macOS and stuff, modern Unix systems, certainly also BSD, if you mark stuff constructor, you I think can have functions run. I think this is not even C++. I think this is in general run when the binary is loaded and at initialization, and I think so as I remember. So yeah, so why is it padding this stuff? So I think it doesn't happen for, and yeah, so there's our wasted space. Just is there something that's expect? Do other, here is someone 2017. So I think it is recent. So the thing is, if we would build the stuff, I use even PowerPC. I have it, PowerPC. But I think this must be somewhat recent, because when we last time built stuff for PS3, it was smaller. Oh, they increased. Could that be a thing? Did they? Wait a second. We should see that the page size should. Oops. The page size should be in the header. Oops. Too many key bindings here. What is the page size? Do we have here somewhere? Start something. Should this not be encoded in there? Something. Do we even? I mean, if that is the case, we should have large page size support. Or maybe the kernel just. I mean, does the kernel probably automatically use 4K pages to probably map all this? I would think. You would think that this is. So 227, when was it? Was it recently? Where are we to? We're at 37 though. Did I mean, we certainly don't want to. We probably don't want to disable features as at large. I mean, I could live with that for PowerPC 64. Especially PowerPC 64 LE. But not for 32-bit PowerPC. That looks extremely... here's also some discussion across tools ng. Let's read that. So yeah, we're not the only one. I mean, this is crazy in my opinion, right? 4K binary in the name. Why don't we just burn freaking everything, right? And this is the stuff like people don't believe me, right? The Debian people is like everything's just working. What does this guy even fantasize their life on YouTube? It's like, yeah, 20 years, right? Every week is something like that. So just some light, of course. Cloudy in Berlin. Okay, this max looks like increased max page size and or common page size definition for PowerPC. They changed 4K to 64K on purpose. Most PowerPC hardware these days is a server based, and yeah, I mean upstream. This is a recurring theme, right? Why not just freaking burn freaking everything? I mean, it's like as long as it's also do you really? I mean. Probably the bigger the binaries, the less it matters, but as you see, having hundreds of small binaries, stuff adds up, right? Especially for otherwise resource limited P3. Where is even the... Where's the patch? Oh, there's attachment. I mean, theoretically, we could do that for PowerPC. I mean, as amazing as T2 is, we can just import this and rebuild everything again, right? Like at least PowerPC. So yeah, given this is amazing stuff, right? Why, if people ask me why should I use T2, because yeah, 25 years of attention to detail, right? Where other people just set it on fire and delete it because who cares about last year's or last decades ATI workstation high-end graphic card stuff. Here we are. Bin utils. Base. Oh, that's a devil. Bin utils. Oh wait, I think did I copy and paste it? Oh wait, you know, we can also. Why have white space damage? Then let's revert that. The syntax is so bizarre, I need to Google that on my own site, although probably I could start to remember that. So the thing is, we could make this PowerPC only 32-bit. But wait, if we build... Okay, we can't make it... You know what, I personally... The thing is, if we name this PowerPC, then we don't get it for our 32-bit default. You know what, we just always do it. Unless IBM donates a Power 8 Plus server, then we can talk. But I think for the time being, you know what, you this shit. So that should revert that, does it? Common page size, what do they? QNX target? Oh wait, so they do Q and X and Z, and if everything else then 64K, okay. Okay, we could actually, if we want to go completely crazy, we could change that for little endian also. Okay, we might not have a little endian definition there, especially if we cross-compile and stuff anyway. So that is reverting that patch. If you have a better trick to do that than that. And yes, my old blog post chat is broken with some embedded stuff because who cares? I need to redo my blog anyway. Let's see if that builds. Probably, if we are unlucky, this does not, but let's see. So the thing is, we probably need to rebuild everything. Not sure if glibc will behave nicely. But okay, this doesn't apply because, nah, shit. Because of course they touched it since then, right? Who knows what they touched since then. So let's see, what will we find? Here is some, oh, okay, they removed the QNX stuff apparently, if you remember, or at least page size, was it that? Common, max and common. Was it common already? Not sure what's going on there. Looked to me like it has been already. Apparently they changed the common page size back or something for whatever reason. I mean, does it? Probably certainly disables the use of. But I wonder. I mean, I wonder if you can't like use if your text can't they just dynamically, like if they have a huge text segment, map that like with 64 pages and the rest with 4K pages? Should this not mostly not matter? But, it's time to write a microkernel, man. It's just getting ridiculously out of hand. I usually use X to rename this, otherwise so this was actually also did I add this already? We should probably rename that. To PowerPC page size. So, yeah, Paul, understood, but I wonder if this couldn't be transparent. I mean, if you have a very huge text segment, I mean, what is the difference? I only see the very last code. I mean, this is only for efficiency for like memory management, like page table work and stuff, right? So this is just having what is it, 16 times less pages or stuff, but couldn't the kernel do that transparently? I wonder, like if let's say you have, I mean, if you have like a small binary like this where like you have 1 or 2 4K pages, then you have, I mean, it only matters for like large binaries like think Firefox or your database. And if you're executable, then like your text section is like say it's like 4 megabyte or 16 megabyte or stuff, the kernel could transparently use that or not. But maybe I'm underthinking the complexity of the stuff. Was cat in core utils, hopefully? Best was. Anyway, I said it before, the core utils. I said it before, I'm not the biggest fan of statically compiled code due to the nature of the single instruction multiple data stuff and other instruction set either extensions. So this compile it once for the lowest common denominator and then wasting performance for your latest, because most people use the distribution operating system vendor shipped stuff, and those they like for Windows and commercial software they never ship most optimized native binaries. They always ship previous generation or like Windows, even decade old stuff like we do in T2 because we want these binaries to just run. So in this day and age of decades of complex instructions at either extensions, static code like this doesn't make the most sense. I'm not saying we should JavaScript everything. We should probably ship some kind of fast recompilable intermediate representation that dynamically forward compatible optimizes scalable vector extension, like having scalable, like virtual scalable vector extensions that optimizes. Sure, it's not, I'm not saying everything's super easy, but I'm only saying this is not optimal. But build PowerPC bin cat. Yeah, that is more what we want to have, right? So that is instead like 66K, 21K, just like we had it in back old days. So 20, I can even use it's. So yeah, actually this, because this is 32 bits, this is exactly, should have exactly been this size. So that much is like some 60% savings, 67% savings with at least for small binaries, which Unix was of course originally made out of small binaries that you can combine. And for the shell scripting stuff, it makes completely no sense for this kind of small binaries. Yeah, I guess we want that I mean, for PowerPC, I mean, the one thing we could argue is, I mean, we could comment that out, and like, if we want to have does that, so what we could do is make this a comment and build 64-bit stuff with that if we say, okay, the 64-bit native. But the only thing is, if you, I mean, this is also not ideal, because if you then build, like some people, I don't recommend it, but some subscribers and viewers and fans and stuff do that. They use T2 because it's obviously the most sophisticated and amazing build system as presented here live on YouTube. And then people use it to build their own PS3 stuff because they want 64-bit, and I know some people build 64 binaries. So, I mean, if for me, I could comment that out. I mean, maybe I should, because, I mean, if you, yeah, but if you then don't know all those details and just build 64-bit PowerPC binaries, it would be cool, but I don't see how we could easily do that, to only do that for latest and greatest little endianness variants of highest performance IBM server stuff. But I don't see that this is possible here like that, due to the nature, and it looks hard-coded for all of PowerPC 64 stuff. Yeah, tough choice. How do we do that? I mean, given that I personally, I mean, you know what? I leave it like that. If you personally don't want that, then it's like, I mean, realistically, most 90+% like P3 users and stuff, they just use our binaries. So maybe also for testing, like if we have it like that and we build 32-bit, 64-bit with 32-bit userland for P3 and G5 and stuff, and 64-bit PowerPC little endian to test all combinations. Actually, maybe we really comment it out. So if we just make it here like a non-patch, like with that or stuff, or let's maybe just use what is the most obvious that this is, maybe that. I think this should work like that to have this commented out. If we reverse it, what is it, 3 times larger, right? Oops. Yeah. Carefully edit that and then stick lower it. So how many? 3 times. Let's retest that. So then we would have the best of both worlds, I guess. And if you build other T2 variants, then you obviously need to do your own due diligence of testing that. Let's see. So that is PowerPC ADM. Let's see, that should only patch here. This works as commented out as expected, but just wanted to double check that. What's the lowest spec PowerPC 64 target with RAM and desktop server? Yes, that is the thing, right? I mean, not only I personally purchased the G5 when it was new in 2004, 2003 actually, I think, plus minus. I said yesterday or so, when my peak G5 was new, it came with 512 or something like that. And of course nowadays I think I have like 9 or 8 gigs. Recently I had 9 gigs in there. Maybe I took 1 gig out because maybe this one, or was it 1 gig or whatever. I took a little bit out, I think, because it was like so small modules, like the original modules, it didn't make sense. And it doesn't matter that other people might only have like a gig in their G5, but the other thing, the really constraining thing is, of course, the PS3, right, where you only have 256 megs of memory. And then it becomes a challenge. I mean, running this stuff is not even that big of a problem on a PS3 because you usually also have swap or using your VRAM as swap. But the bigger thing is initRD, right? And the problem with initRD is that it needs to be loaded and decompressed. So you need loading that in memory, decompressing that, and decompressing all the zeros in uncompressed tempfs, because tempfs, due to the implementation, previous video some year ago, is uncompressed. It's also silly that in 2022 we have not compressed page tables for tempfs, but it's not my kernel. And so the memory requirements for the boot process becomes like twice as large, and then you need them in tempfs and have them mapped and relocated in with the relocation stuff. So mapped from tempfs, probably 0 copy plus relocations. And as people reported, this stuff did not boot on PS3 anymore because you have the kernel in memory, you have some overhead, you have dynamic data, and you have the initRD, the compressed one, the uncompressed one during decompression, and then you obviously run out of memory uncompressing that. So theoretically, yeah, we need to test all this stuff, so that means we actually should rebuild all this stuff. Unfortunately, we could, I mean, should we maybe quickly, let's quickly double check some stuff. That means building 64LE, oops, 64LE, and just do this in one terminal because that's what we like, 6432 user space. And so we use on the PS3 for the G5, because that is also a little obviously performance limited and stuff, but even more so the PS3, we default similar to UltraSpark and probably even MIPS 64. We default to 32-bit userland exactly for that reason, right? For saving memory and cache. So it's even performance, right? So pause the 32 userland on 64-bit kernel legacy. Bus stuff. Is there legacy bus stuff? Raspberry Pi saves a lot of memory related problems, including kernel swap block and yeah, stuff like that. So we should have then okay, that did not had. Why did so the good is that we tested that somehow. This didn't had the desired effect. It will not build. Okay, maybe we can't have it that easy. I wonder if so much to testing, right? If I would have blindly rebuilt that, assuming that it works, so much to, yes, invest like 2 minutes of sanity checking your stuff before you spend hours rebuilding stuff. That was bin utils page size. Wait, why is that? What? 26. What? 13, what is this? Ah, this is some bloody PM time, because probably the bloody ENUS local. Why is one using, what? Date is using, that is crazy. That is using a sane time? Locales. I would use C, I mean, maybe I should update my system to C.UTF-8. Extreme, this localization stuff is, I mean, who wants a bloody 12-hour clock, right? So confusing. What is here with this page, size page? What have I done? That is strange. 2, 2, 5. What? Why is this page size? What am I missing? What the heck? The Unicode shit? What the heck happens with my patch? I don't get this. How is it happening? Where's my patch file? That is because we have a freaking overlay here. That is why we have a PowerPC. Why did we have that? All right, because there was another previous video. Oh, so many regressions. Why don't we freaking set everything on freaking fire, man? So broken. I mean, how can everything freaking be so broken? I even forgot already that we. What it even was, I think it was internal assertion, right? It was, oh man, so many broken things. I already start to forget this. There was something with, I think, assertion, internal assertion with. This is a dumpster fire, man. Can we SCN? Can we subversion copy a? Can we SVN CP that? I'm not sure if that will result in a. Okay, we could do that, but. Yeah, not entirely sure. Anyway, might not be as efficiently encoded as I would wish, but that's what it is. Let's hope the patch applies there too. Maybe not, depending if they have this QNX stuff in there. Who else? Is there a performance hit for 32-bit little endian? What exactly do you mean with that? There is not really 32-bit little endian support for PowerPC. My understanding is that CPUs at times, maybe most CPUs would support that, but the problem is nobody is supporting and implementing that, because most systems, is my understanding, at least is what the Linux kernel developers told me, is when there were discussions decades ago, that most systems don't have endianness swapping hardware in the system controller hub chipset thing, so that you couldn't like have little endianness hardware swapped and swizzled on the bus like for PCI access and stuff. So it would be extremely hard and error prone to write drivers on most systems, because you would have strange endianness artifacts, like writing like your little NUS CPU, like you would potentially see byte swapped and swizzled data on the PC I was told. So, which is why the Linux kernel never implemented that for those systems, and it should not be impossible. But I mean, you also don't. I mean, especially if it's like yeah, I mean, this stuff is a little bit undefined and hard to define there for, like, if you have an otherwise big NUS hardware-based system supporting that on buses, but yeah. Anyway, so yeah, basically it's only, I mean, even theoretically, I will try someday, I said this before, I will try this someday on the P3 and G5, but in user space at least, and see what happens. Probably should work, but that is why it's only supported from Power 8 and up or something, due to that system level hardware support thing. So yeah, this is expected. So there you see the difference, right? So this would be, instead of, so this is 32 bits, so now it works as expected, and the PowerPC 64 LE board, so because this is native 64 bits, like, yeah, I guess for PowerPC 64. So for those people who are triggered with the IBM latest and greatest stuff, they, of course, they still get that with that build. But yeah, so tested that. Then it's probably time we only need to rebuild all the 32-bit PowerPC stuff. Like, yeah, there's always one more thing. It's crazy what release engineering went into. I mean, besides, we should have released something for Christmas, although it was unfinished, but the amount of polishing, the amount of small things, I mean, it's of course crazy that there's always one more thing. But this, but that, but that bug, but booting that, but the PS3, but yeah, it's crazy. Probably a epic thread rip. That freaking windy now. So let's build that, and let's build. So yeah, it's kind of exactly what what I expected. Didn't really expect page size. I thought some other nodes and random stuff, but. So yeah, PowerPC we have there, and that is our fan stuff from the previous video, right? Yep, still need to commit that though. Should we? Yeah, I commit this after the build, after the video. But yeah, at least we found another mystery, improving that. That is certainly another. I kind of lose overview. I actually need to check with my commits on trunk. I mean, I already merged all the very important stuff to trunk. It's like, yeah, maybe I should stop running T2 on this release quality that you would otherwise only expect from the most commercial maintained Linux distributions, and YOLO it more like others and YouTubers do. But anyway, that's the first video. I hope you learned something. Hey, 0 frames because it was LTE. I 1 freaking hour, of course it is. Hope you learned something. And don't forget to like, subscribe for all the next videos and live streams and fun stuff to come. Don't see my mouse cursor. Where's my mouse cursor? Where's my left hand? So there it is.